Okay, so have you ever felt like you're just drowning in digital stuff? Terabytes of photos and videos and like that voice memo you recorded 2 years ago and just can't bring yourself to delete.
Right.
Now imagine that times, well, basically the entire internet.
Okay.
And suddenly you've got a sense of what people working in big data are dealing with these days.
It's true. And, it's not just the sheer amount of data, but it's the variety too, right?
Yeah.
I mean, we've gone from a time when there were a few really massive data files, think like scientific data sets, financial transaction logs, to this explosion of these smaller pieces of data that are being generated all the time.
Instantly. Yeah.
Yeah, like everything from your smart toaster to self-driving cars, they're all throwing off information constantly.
So that's where, at least from what I understand, Apache Hadoop Ozone comes into play. From what I've been reading in these blog posts and these tech specs, Ozone is basically like a total reinvention of the way we store and manage all this data.
Yeah, it's a pretty big shift from what we're used to. So like the current standard is HDFS, which it was a revolution in its time for
Yeah.
sure. But
Mm-hmm.
imagine you needed to find, I don't know, a single receipt, right?
Yeah.
But it's buried in a warehouse. And this warehouse is stacked floor to ceiling with these huge shipping containers.
Oh, okay, I'm with you.
So HDFS, it's great for those big containers, those huge files, but not so much when you need to find one receipt out of millions.
Right, right.
Ozone is more like, I don't know, it's like this well-organized, futuristic library where every single thing has its own place.
So instead of that chaotic warehouse, we've got order. But it's not just about keeping things tidy, right? This isn't just about aesthetics. This architectural difference has some real implications when it comes to speed and how efficient the whole thing is.
Absolutely, yeah. One of the things that really struck me when I was reading about ozone was, well, how ambitious it is. Like, we've got articles here claiming that ozone can handle over 100 billion files
Whoa.
in a single cluster. Just let that sink in for a second. To put that in perspective, that's like storing every photo ever uploaded to Instagram and then some.
Okay, so that's just mind-blowing. How does it actually do that? That's like
Yeah.
a fundamental change to the way that the data is structured, right?
It really is, yeah. The way ozone does this is by using something called storage containers. Think of like, well, those standardized boxes that you always see on cargo ships.
Yeah.
It's like that. Only in this case, these containers, they hold chunks of data instead of, whatever they put in those shipping containers. And each of these ozone containers, it can hold up to 5 GB each.
Okay.
And that granularity right there, the size of those containers, that's a big deal because it makes it way more efficient to make copies of the data and manage where everything is.
So when you say replication, you're talking about backups.
Yeah.
Right. Like making sure that even if one server completely crashes and burns, the data is still safe.
Exactly. So Ozone uses something called the RAFT protocol. And what this does is it's constantly synchronizing the data across a bunch of different machines, like in real time.
So is that kind of like having a bunch of different constantly updated copies of like a Google Doc or something?
Yeah, that's a really good way to think about it.
So even if one person loses their connection, everyone else can keep working, right?
Exactly. And that kind of robust replication, that's super important because of how Ozone works with these containers.
Okay, so we've got all these containers, right? And they're constantly being backed up, kept in sync by this RAFT thing. But what I'm kind of wondering is, how does this all actually work in practice? I mean, does having all these containers instead of just like one big pool of storage, does that slow things down at all?
You'd think so, right? But it's actually the opposite. This containerized approach, this is a big part of what makes Ozone so fast and efficient, especially when you're talking about like reading and writing data.
So no more waiting like forever for a huge file to download or to back up to the cloud.
You got it. See, Ozone uses what's called a random read-write approach.
Mhm.
It's kind of like, imagine you're looking for a specific thing in a library.
Oh, right.
Right?
Got
So
it.
instead of having to like rewind a cassette tape just to find a particular song, you can just jump straight to that track you want.
Oh, okay.
It's the same idea with Ozone. You can get to the specific data you need inside a container without having to read through a ton of other stuff you don't.
Right. Makes sense. But what about those truly massive data sets, the ones that HDFS was built to handle?
Ozone can handle the big stuff too, don't worry. Remember that warehouse analogy we're using? So Ozone, it's like it can store those massive shipping containers just as easily. It's all about having that flexibility to manage data at different, sizes, whether it's a tiny file or a huge data set.
Okay, got it. So we've got containers, we've got replication. What else makes Ozone's architecture unique? One thing I keep seeing in all this research is this erasure coding thing. What is that all about?
Erasure coding. That's where Ozone gets really clever. So it's a way of making sure that the data is safe and sound, durable, but it actually lets you use less storage space compared to just like making a bunch of copies.
Wait, so you're saying Ozone can actually like save you money on storage costs? How's that work?
Okay, so imagine you have a really, really important photo and you want to back it up. So instead of making like 3 identical copies on different hard drives,
Yeah.
what if you could cut that photo up into, say, 6 pieces?
Okay.
And then, and this is the really cool part, you use some math, some fancy algorithms to add in some extra information, and then you spread those pieces across your different storage drives or even across the internet.
Okay, I think I'm following so far.
So even if a couple of those drives fail or a server goes down, you can still take the pieces you have left and that extra information you added, and because of the math, you can reconstruct the original picture perfectly.
Wow. So it's like some kind of digital jigsaw puzzle where even if you're missing a few pieces, you can still see the whole picture.
Yeah.
That's amazing. But how does Ozone handle all that math? All that data juggling? That's got to be a lot for any system to manage, right?
That's where Ozone's, optimization for modern hardware comes in. It's built from the ground up to use things like NVMe drives, which are crazy fast.
NVMe drives. Okay, so for the folks at home who aren't, hardware geeks like us, what are those exactly and why are they important for how Ozone works?
Think of NVMe drives like SSDs, solid state drives, but like way faster. We're talking significantly faster than traditional hard drives.
Yeah.
And Ozone is built to take advantage of that speed. This is super important for the Ozone Manager especially.
And just to remind everyone, the Ozone Manager is kind of like the head librarian, right? Keeping track of all those containers and making sure we can find the data we need.
Exactly. And because it's constantly handling, requests and managing all the information about potentially billions of files, it needs to be as fast as possible. And that's where these NVMe drives really shine.
So Ozone isn't just designed to efficiently store and replicate data using these containers and this erasure coding thing, but it's also built to access that data as quickly as possible thanks to these super fast NVMe drives. It's like a perfectly tuned storage orchestra. But, there's one piece we haven't really touched on yet, and that's how all of this integrates with the systems people are already using. I mean, what good is all this data if you can't actually use it, right?
That's a really important point, and it's definitely something the Ozone developers have thought about. Ozone is designed to be super versatile. It plays well with, like, the existing Hadoop ecosystem, but it can also hang with all the new cloud-native stuff, too.
Okay, so it can speak the language of both the old guard and the new kids on the block. That's got to be important for people who are thinking about switching over.
Absolutely. For those folks who are already using Hadoop, Ozone provides Ozone FS, which is like a bridge. It lets all those familiar Hadoop tools work with Ozone without having to learn a whole new system.
So no need to completely rip and replace your entire infrastructure to take advantage of what Ozone can do.
Exactly. And for those who are looking ahead, to the future of cloud computing, well, Ozone is completely compatible with the S3 API.
Now, for those of us who don't speak fluent tech jargon, what does S3 compatibility actually mean?
Think of S3 as like the universal language of the cloud. It's what all the major cloud providers like Amazon Web Services use. Because Ozone is S3 compatible, it can talk directly to this whole world of cloud tools and services and applications.
So it's about way more than just storing data efficiently. We're talking about like a whole universe of possibilities opening up for analyzing, sharing, and actually using that data in ways we haven't even thought of yet.
That's what makes it so exciting.
Yeah.
Ozone isn't about playing catch up with all this data. It's about actually using it to do new things.
This is where it gets really cool for me. We started with a messy warehouse analogy, and now we're talking about a future where data is like organized, accessible, and infinitely more useful. It's a whole different way of thinking about it.
It really is, and it makes you wonder, what if this technology that was originally built to handle the insane scale of big data, what if it changed how we all manage our everyday files?
So we spent all this time talking about how Ozone is like purpose-built to handle these absolutely massive data sets, the kind that would bring a normal computer to its knees. But something you said earlier really got me thinking about this idea of Ozone being about way more than just big data,
Yeah.
Like what if this technology eventually like trickles down to the way we all manage our everyday files, our photos, our music, all that stuff.
That's a really interesting thought, right? I mean, if ozone can wrangle billions of files with this speed and this reliability, imagine what it could do for, just your average person's digital life. No more lost files. Backups would be instant. Everything synced perfectly across all your devices.
It sounds almost too good to be true. Like we're talking about a world where every photo you take, every video, all those important documents we always forget to back up, it's all just safe and organized and accessible from anywhere.
And that's not even the coolest part. Think back to that random read-write thing we were talking about earlier.
With the containers, yeah.
Exactly. What if you applied that to something like cloud storage? You'd never have to wait for like a huge file to download again. You could just grab the parts you need instantly. It'd be like skipping to a specific scene in a movie.
So no more waiting for a 2-hour video to download when all you want is to see that 30-second clip your friend told you about. That would change everything.
Yeah.
But honestly, like, how realistic is it to think that we might actually see Ozone powering these everyday consumer storage services anytime soon? Well, it's definitely not impossible. I mean, think about it. The core ideas behind Ozone, this container-based architecture, this RAFT thing for keeping everything synced up, that S3 compatibility we were talking about, those are all things that could totally work for, consumer-level stuff.
And don't forget that it's all open source. So there's like a whole community of developers out there who could potentially help make this a reality.
Exactly. Not to mention how fast hardware is getting. As these NVMe drives get cheaper and more people start using them, those speed and efficiency gains you get with Ozone, those are going to be even more noticeable, even at a smaller scale.
It's kind of wild to think about. This tech that was designed for the almost unimaginable scale of big data, it might actually completely change how we manage our own little digital lives someday. Just goes to show you, you never know where innovation is going to lead. That's what I love about this stuff. You're absolutely right.
Well, I think that's about all the time we have for today. A huge thank you to you for joining me for this deep dive into Apache Hadoop Ozone.
The pleasure was all mine. I had a great time.
And to everyone listening, thank you for joining us on the deep dive. We'll be back next time with another deep dive into the world of technology and innovation. Until then, stay curious, keep learning, and as always, keep asking those big questions.